Hello, everybody. My name is Simonas Stankus. I'm one of the co-founders of Lithuanian-based startup Inbalance Grid. We are working on EV charging solutions, and our goal is to make charging available everywhere. I would like to start with a kind request to the audience to imagine, hopefully, very near future, when we will have 100% of all the cars in our streets as EVs. So obviously, we'll have cleaner air, less CO2, less noise in our streets. But at the same time, we will have some issues in the distribution grid because the grid will be not able to keep up with the demand. And in another side of the equation, renewable energy will be also unstable and will also give some strain to the distribution grid. Our distribution grid was not made for unstable producer and unstable user. So there are always two options in our life. The one is hard one and another is the smart one. And the hard one would be to replace current infrastructure with wider cables under the ground. And the smart one is, from our perspective, is to adjust smart charging and smart scheduling. Unpredictable EV charging is unstable, chaotic, and concentrated in time and location. And EVs are becoming a huge strain to the grid. And to prevent that strain, we need to think about these solutions. As I said, one of them is reconstruction, and another one is smart solutions. And this strain comes not because we are not able to produce and supply electricity, but because the distribution grid is limited and, as I said, is not made for EV charging at first. But I would like to zoom out a bit to our behavior that we have today. The main problem with EV charging comes because we want to charge our cars as soon as possible, right here, right now. The same we did with, and we do with our standard cars, to fill up our tanks as soon as possible. And this behavior creates a strain in the grid, and that strain basically overloads the secondary substations, and we need to do that expensive reconstructions. And for reconstructions, we need to have political will to do that. We need to invest quite a lot of money, and it takes a lot of time. And of course, time, money, it stops the adoption, the smooth adoption with EVs in our streets. But by its nature, petrol and electricity is different commodities. And to fill up our tanks, we need to go to the centralized location. And to fill up tanks, because there are a tank under the ground, and we do not have tanks under the ground in all the buildings. And talking about electricity, it is completely different. We have electricity everywhere already today, in retail stores and shopping malls and other locations. And those locations is perfect for EV charging, and we can do some flexibility on top to reschedule the charging. Today, the current state of EV charging is like this. We have uncoordinated charging sessions. We have no integrations with the grid. We do not know what the grid capacity is. And the most important part, we are not integrated renewable energy into the energy mix. And consequences of that is that we have really high expansion costs, and we have a slow adoption in the continent, in Europe. And we know, everybody, about the goals of Green Deal, that we want to have hundreds of thousands EVs in our streets very soon. And if we want to reach these results, we need to start to think how smart solutions like smart scheduling could help to do so. And let's look to our current behavior. I think the one who's working on charging already saw these numbers, that usual average distance that European driver drives per day, it's about 32 kilometers. And we usually park our cars for 20, 23 hours where? In shopping malls, residential areas, retail stores, offices, hotels, and etc. And all those locations, by its nature, as I said, they have electricity already. We do not need to dig, a tank under the ground to be able to charge cars there. To build the main question is how we are using those locations and when we are using charging at those locations. From our opinion, if we are adjusting smart scheduling on people's behavior, since people are leaving their cars at those locations for majority of the time per day, we can reschedule charging in time. In this case, we can help to reshape the overloads. And if we are taking smart scheduling or smart charging into the consideration and adjusting Inbalance smart charging engine to tackle this problem, we need to go through main 3 steps. One very important step is data collection. And in data collection, we need to receive data about 3 main steps, 3 main pillars. Is first of all demand, about charging sessions and user behavior to predict and adjust charging and commuting patterns. The second one, we need to receive information about the supply, the level of renewable energy in the mix. And the third one is the grid, its capacity to avoid grid congestion events and maximize grid utilization. Afterwards, we're taking all the data to Inbalance charging schedule engine, where all the magic happens. We are adjusting artificial intelligence, we're adjusting machine learning, predictive analysis, and all other functionality on which we worked in the last 3-4 years. And we are offering the best offers for the end consumer when, where, and how much they need and they should charge their cars. And you may say that everybody wants to charge their cars as soon as possible, and we can't change that because that behavior came together with our behavior from the petrol cars. But I like to speak about data. So last year we had about 30,000 charging sessions in our network among Baltic states, and 99 point something of all the charging sessions and all the people decided to take part in these kind of activities to charge the car not as soon as possible, but when there will be the best time to do so, and everything is based on the price incentive. So what I'm trying to say, that people already with today's behavior already can participate in smart scheduling solutions. And I'm pretty sure that if we would adjust these kind of solutions into all CPOs, we would be able to reshape these load curves down. As you can see, we have the major, the biggest amount of charging sessions in the morning and in the evening. And if we could reschedule the charging sessions from the morning, for example, to the noon, we would be able already to give a better price. We would be able to, first of all, not to reconstruct the grid and be able to charge car at that location. And very important part that during noon, we are receiving quite a lot of renewable energy from the solar plants. And we would be able to use that energy in charging our cars. So that's our main idea. And by adjusting this kind of functionality, we would be able to give much better charging availability. We have calculations that about 40% of current parkings, imagine 40%, would be able already to have charging points there without any reconstruction of a grid. So imagine the savings we would have regarding capital expenditures. And of course, since we would have lower capital expenditures, we also would be able to offer better price for the end consumer. Also, about 30% of more renewable energy from our calculations would be used in charging events. And of course, grid upgrade avoided. That's a very important part as well. We think that about 2 times improved grid efficiency and utilization would be reached by adjusting these kind of solutions. I think that Lithuanian guys that are here already know that Lithuania about a year ago invested 100 million euros into battery parks to help to reach flexibility in the grid, to help to adapt more EVs in our streets. And one battery park has a capacity of about 50 megawatts. And 50 megawatts, from our calculation, gives the same flexibility as 30,000 EVs. Of course, I'm not saying that we do not need to invest into such investments as battery parks, but let's think that we trying to encourage people to buy electric vehicles, and electric vehicles with its batteries would help to reach similar flexibility as battery parks. So I think that dual solution would help governments to have way better flexibility, and EVs and primarily charging point operators would be able to take part in the balancing events. So once again, capital expenditures in terms of investing into batteries is important, and we need to do that. But at the same time, we need to think how we could manage currently chaotic charging sessions around all the countries, and how we could manage those charging sessions to help governments to balance the grid. Let's talk about the future of EV charging, how we see it and how we would like to see it. We think that charging scheduling algorithms of functionality that we are working in, and we are not the only company that are working on these kind of solutions, would help to make charging available everywhere. As I said, it's our primarily goal, and we believe that smart charging and smart scheduling would help to reach that. And this kind of functionality would help us to prevent huge capital expenditures, and would help us to also put the renewable energy into the mix. And of course, if we'll have a lot of charging stations around us, I'm pretty sure that adoption of EVs will be way better than we have today. Because what concern we hear from the end consumers mainly is that we need to have more charging stations, to have motivation to buy EVs. And and the main thing that the grid would be able to handle the demand of charging that is growing very fast. And to sum up, as you said, that our grid is facing quite huge issues and challenges, and it was not made for chaotic. It was not made for unstable producer, meaning renewable energies. It was not made for unstable user. I'm talking about EV drivers. And there are 2 solutions. One, to invest a lot into the infrastructure reconstruction, and another is a smart one, smart scheduling, smart charging. That would enable us not only to save quite a lot on reconstructions, but also to adjust renewable energy into the power mix, and would help to have way more EVs in our streets. So that's on what solutions we are working, and thank you for your attention today.